All right, folks, let's look at page 73. This is a warm-up for your quiz on the history of the atom and isotopes. If you have not yet had some time to work on this warm-up, then you can pause this video and take 8 minutes to do the warm-up. And after 8 minutes, you can play the video. So go ahead and pause it if you haven't already. Alright, and at this point, if you're playing the video, it's because you have already finished the warm-up. So, let's go over it. Number 1, describe how each scientist contributed to our understanding of the structure of the atom. What experiment did they perform, if any? And then it says, how did? I think we were intending this to be like, how did they model the atom? It's fine. Anyway, Dalton had the first major atomic theory. And there were several postulates or theories within his theory that we now know not all of them are true, although at the time he had no way of knowing they weren't true because we didn't have the technology to figure that out. So regardless, his atomic theory said that several things. Said, number 1, that atoms of the same element are identical. His theory said that atoms cannot be subdivided. And his theory said that atoms cannot be created or destroyed. We now know each of those is false. We know because of isotopes that atoms of the same element can be different. We know that atoms can be subdivided into protons, neutrons, and electrons. And we know that atoms can be created or destroyed through something called a nuclear reaction. But Dalton had no way of knowing any of those things. Next up, Thomson. He's credited with discovering the electron using what are called cathode ray tubes. And he said that electrons are negative. And he had what's called the plum pudding model. Rutherford had the gold foil experiment. Which discovered positively charged nucleus with it. That's what that experiment did, because the radiation alpha particles bounced off the nucleus instead of moving straight through it. That's how he knew that the nucleus existed, because they the alpha particles were bouncing off something. So he concluded that there's a dense nucleus in the center of the atom, and the rest of the atom is mostly empty space. And then Bohr used what's called the hydrogen emission spectrum to discover that electrons have fixed orbits around the nucleus. So he developed what we call the Bohr model, or the planetary model. Of the atom. For this next part, this table, we're given the name of an isotope. We have to find mass number, atomic number, protons, and neutrons. It might help to remember Ape Man. Ape tells me that the atomic number is equal to the protons is equal to the electrons, so I know atomic number and protons are going to be equal. And the man tells me that the mass number is equal to the atomic number plus the neutrons. So if I know atomic number and protons are the same, then protons plus neutrons will get me the mass number. It helps to know that when an isotope is written like this, carbon-13, carbon-14, these numbers after the hyphen, those are the mass numbers. So whatever number they give you, find the column that says mass number, and it's that same number. 13 is the mass number, 14 is the mass number. To find the atomic number, you're going to have to go to the periodic table and find carbon. And carbon on the periodic table, remember this top number is the atomic number, and if you forget, it's even labeled in the legend for you. Carbon's atomic number is top number 6. And since both of these are carbon, the atomic number for both of them is going to be 6. I know atomic number equals the number of protons. That's what Ape Man tells me. So there are 6 protons because the atomic number is 6. And if the mass number is atomic number plus neutrons, that means that the neutrons are equal to the mass number minus the atomic number, or mass number minus the protons. So if I take 13 minus 6, that'll get me 7 neutrons for carbon-13. Or 14 minus 6 will get me 8 neutrons for carbon-14. For number 3, describe how the isotopes of an element are the same and how they are different. They are the same because they're the same element, which means they have the same number, the same atomic number, and also, therefore, the same number of protons, and when the atom is neutral, the same number of electrons. What's different about isotopes is that they are different masses because they have different numbers of neutrons. All right, at this time, unless Miss Woodlock gives you other instructions, it is time for your quiz.